Okay, so now we've got our three trig identities. So I'll write them out here so we've got them easy to see. Sine squared theta plus cos squared theta is 1. I've got 1 plus tan squared theta is sec squared theta. And I've got 1 plus cot squared theta is cosec squared theta. Fantastic. We're going to use those three results to help us simplify some expressions. So in this very first one here, I've been given cos squared and then angle A over sine squared angle A. Well, this is just going to be cos on sine. Now we said in the last lesson that cos over sine is cot. So this would be cot squared A. A rather nice easy one to start. And we didn't have to use any of those results there. The very next one in B, I've been given sine squared 2x plus cos squared 2x. Well, I need to see if there's any sines and cos squareds together, and I do have those here. And I know when I've got that same angle, see theta theta, except in this case, it's actually going to be 2x and 2x. Well, it's just going to be 1. And that's based off Pythagoras' theorem in the unit circle. Okay, let's have a look at question C now. So I've got 1 minus cos squared beta. Okay, it's not a B, it's beta. It's a Greek letter. Now, I'm going to see if I can find any 1s and any cos squareds in any of those expressions. Okay, well I've got a 1 here and I've got a cos squared, but they're not together. So what I could actually do is from that result, that very first one, so that first result was this. I'm just going to write it with the angle beta. Okay, now I could do this way. I could say, well, I might, if I throw the cos squared beta to the right hand side by subtracting it to both sides, then I'll have 1 minus cos squared beta is equal to sine squared beta. And that's going to be my result. Now, another way to approach this is by using substitution in that same result. So I could actually rearrange the whole equation to make cos squared the subject and sub that in, or I've already got 1 as the subject here, and I've got a 1 here. So what I could do is I could actually replace this one with a sine squared and a cos squared. Alright, so let's do that. I'll just unhighlight those things. Okay, so that means that instead of 1, I'll have sine squared beta and cos squared beta. And then I've got my minus cos squared beta. Now, collecting like terms here, the cos squareds will cancel, leaving just sine squared beta, which is what we got earlier. So that's 2 different ways to do this question. Okay. Now, question D, you can just have a look here and you can easily see it. 1 plus tan squared, and then it's not an A, it's alpha, a Greek letter. 1 plus tan squared, well, I've got that exactly. So that one there is actually just going to be sec squared alpha. Okay, that's just a simple substitution. So that will be sec squared alpha. Now let's do question E and F. Okay, I might have some space here. So for question E, I've been given sec squared x minus tan squared x. So I look at my 3 trig results and see which one matches or what components are there. Okay, well, I've got sec squared. I've got a whole equation where sec squared already is the subject, so I can replace that sec squared with a 1 plus tan squared. So let's do that and see where it takes us. So I'm replacing the sec squared, this one here, with 1 plus tan squared, okay, x, okay, because the angles were x's, minus tan squared x. Collect like terms and you'll see that the tan squareds will cancel, leaving simply 1. Okay, last one now. We've got cot squared and cosec squared. Okay, once again you can see that there's an equation here that actually has all three or all two of them in there. So I'll replace the cosec squared with this, okay, it's a substitution, and solve or simplify from there. So I'll do that over here on the right. Okay, so I was asked to simplify cot squared theta minus cosec squared theta. Now that will be equal to cot squared theta minus, and then I'll substitute this in for cosec squared theta. Now it's important that we can only do these results when they're squared. So if it was just a sine and a cos, it wouldn't be the case, you wouldn't be able to use these substitutions. You might have to do some further manipulation of the terms. But in expressions, you can't really change the value of them. So you need to be careful there. The cot squareds will cancel because of the negative here. So I'm just left with -1. And that's my result. Okay, so that's some simplifying of some trigonometric identities. Okay, we'll have a look at proofs in a minute.